This app is an app that allows us to choose the SN or AN. Okay, so it says enter the formula for the nth term. Do not include n x to the power n. So in this case, we've just done 1. So this represents the basic power series of x to the power n. And so essentially it is our infinite geometric series as long as x is between -1 and 1. And this power series expansion, if we have just one term, we have a linear function. 2 terms, we end up with the quadratic, cubic, etc. It goes like this. And what this is doing is it's mimicking some function. And since we've already seen this one before, this is an example that we've looked at before previously. This happens to be the formula for, or the power series expansion for 1 over 1 minus x, which happens to be the infinite geometric series formula. Okay, it's just it's a rearrangement or just a version of the infinite geometric series formula of a over 1 minus r. Okay, in this case, a is 1, and our r is going to be the x value, and it only will converge between -1 and 1. So if I draw in, I can actually draw in the value, and guess what that series is? We're going to end up with 1 divided by bracket 1 minus x, okay, and close that bracket off. So there's our 1 over 1 minus x function. We can see that our power series is centered at 0, so it just touches at x is 0, but it doesn't converge for any other values. But as we increase the number of terms, we can see that it starts to follow the curve between -1 and 1. It follows the curve better and better and better. Okay, so as we increase the number of terms, it gets better and better and better. But once it gets past the -1 and +1, it definitely diverges. On the +1 side, you can see that there's an asymptote and it doesn't go down on that asymptote. And on the left-hand side, it's just kind of bending away from that when it's even. And even when it's odd, you can see that from -1 to the left, it's still diverging. Okay, so this is dependent on the ability for this function to converge, or this series to converge.